Oh, hello, everybody. I am Carlos Frajuca. I'm from FURG, Federal University of Rio Grande, in São Paulo, Brazil. I'm going to tell you about my work, that is a resonant mass gravitational wave detector in the 100 kilohertz range. It's a work done with my students, André Rogério Cardoso Prado, and my collaborator, Nádia Simão Magalhães from IFSP, Brazil. I'm going to tell you about my abstract that you can read in the booklet of the event. This is my outline. First, I'll tell you about the detection of gravitational waves, the first detection, the gravitational wave frequency range, the rest of the mass gravitational wave detectors, the proposed detector sensitivity, a comparison with a laser interferometric gravitational wave detector. This is the first gravitational wave detector. Here you can see the signal that was detected in the LIGO detector in the United States. And you can see here that the strongest signal comes here in a frequency close to 128 hertz, both in Livingstone and in Hanford. This is a sketch of the laser interferometric gravitational wave detector that made the detection using interferometers to detect it. And this was a catalog made with more gravitational wave detectors. And as you can see in the signals, all of them, the strongest signals happens around 150 hertz. And that's why this attach made the detection, because it has a bad sensitivity around the signal. There was before this kind of detectors, there was a network of resonant mass gravitational wave detectors around the world that they are easily calibrated. It's a mass, a cylindrical mass, 3 meters long, that vibrates on a gravitational wave pass through. But maybe one of the problems that not allowed the detection was the frequency range. All of these detectors, and in the right side here, you can see an example of this detector. This is the Allegro that operated in the United States for almost 2 decades. There was a network of such detectors around the world, United States, Europe, and even in Australia, but they didn't detect any signal. Maybe because the range of detection was wrong. They operate around 1000 kilohertz, and the detection here was around 100. Then our idea is to make a different shape, this shape like a tuning fork. We make a simulation of such vibration. And as you can see here, it have a very clean mode when the gravitational wave pass through. We are going to attach some transducers on these bars here and measure these movements of the detector. And when I can see here in this place here around the top, where it is in blue, there is almost no movement. That will be a good place to attach the suspension to the system. This is the electronics. We think you operate that using a SAIFR transducing using microwave, parametric microwave transducing to measure the vibration of that mass. And this is some characteristics we make it to calculate the sensitivity of such a detector. And this we have the strain sensitivity is close to the quantum limit. We can't improve that without making some squeezing. This is the detector of the LIGO. This is sensitivity of the LIGO detector that makes the first detection. And we compare it with the sensitivity of our detector that goes very close. This is what I wanted to tell you about in the time I have. Thank you for your attention.